Okay, thank you. And before we begin, I'd get everyone to put your hands together and give the organisers of WordCamp Sydney a round of applause. As Jordan said, I work as a lead engineer on 10app's open source practice, where I'm sponsored to work on WordPress core for about half my time. For WordPress, I'm a core committer and I'm a member of the WordPress 6.7 release squad. And one of the things I try and keep in mind when I'm working on WordPress core is that WordPress is used for all sorts of websites. Everything from the completely fictional Family Grocers a few minutes from my home, and you'll see why it's fictional, to the somewhat less fictional White House, where the current renters are preparing for their eviction. And for full disclosure, the White House is one of the sites that my employer is well known for working on. But all that happened about 12 months before I joined the company, so I have absolutely no idea of any of the specifics. But I'm talking about whitehouse.gov because it's an example of a big enterprise build. And for the last 8 years or so, it's these sort of enterprise builds that I've been working on. I've worked on sites for global banks, national news outlets, and other big businesses. But in a very real sense, when I'm working on WordPress core, I'm mostly working on sites like this, the small or solo business that hires a freelancer, designer, developer to build a website for them. And in my experience, it's the green Family Grocers of the world whose sites tend to get hacked. Often the problem comes from theme or plugin failing to follow best practices. And to demonstrate this, I've created another fictional site for the talk, the Scarlet Family Grocers. The Scarlet and the Green family are sworn enemies. I don't know why, ever since they appeared in Cluedo together. And in my imagination, the Scarlet family have ripped off the Green family's design. But in this talk, I'm going to need to be a little bit less subtle than that. For the big enterprise builds, the Hollywood image of a hacker is somewhat accurate. If you take away the hoodie, the ski masks, the gloves, and the Matrix background. It's people sitting at a computer targeting a particular site, either for the kudos or for more malicious purposes. So the really big sites need to take some steps that it's not necessary to take for every site. For example, the White House requires users be on a particular network to access the admin and limits the REST API to those users. They've also gone for a little bit of security through obscurity by removing the generator meta tag and other markup with the version number in it. But if you know where to look, it doesn't take too long to learn that they're running the latest WordPress 6.5 release, or at least they were last time I checked. For smaller sites, the steps that the White House is taking can help, but they're not always necessary. Rather than individuals seeking kudos, a much more likely situation is another hacked server and site that's operating as a bot attempting to share the love around. Why target one heavily protected site when you can actually hack thousands of smaller sites in a fraction of the time? And it's my firm belief that smaller sites tend to get hacked more often than enterprise sites for one simple reason: a failure to follow best practices, or in the worst cases, a failure to follow even good practices. In my more frustrated moments, I sometimes believe that it's only the big enterprise builds that follow the best practices. And in reality, this is really unfair. A lot of freelancers do their best and do build secure sites. However, I think a big problem within WordPress circles comes from actual educational resources. Much of the content on sites aimed at developers doesn't follow good practices. It's not my goal to call out any one of these sites with what I consider poor quality code on it. The lack of good quality educational resources is so widespread that if I was to call out one site, I'd need to call them all out. And frankly speaking, I sometimes think that that could be a session all of its own. All that to say that when I've pulled an example from a website, I've refactored the code to try and make my point while making it more difficult for you folks to Google it. This code sample comes from the developer resources of a fairly popular plugin. It takes some site-specific metadata from a user's profile and displays it on the front end of the site. And these are the problematic lines. They take untrusted user input and output it to the page. There's no consideration as to whether the data is safe or unsafe. And unsafe data can be one of two things. It can be either intentionally malicious or just a simple typo made by the user. And trusting untrustworthy data is an example of why sites get hacked. Let's revisit our friends at the Green Family Grocers for an example of a site using untrusted data. Being savvy social media users, the Green family promote themselves on social media and link users to use special discount codes on their site. The discount code is simply a parameter added to the URL of the website. Try and ignore the actual code. I was called in to do this talk yesterday, so the slides are a little old. The parameter is used to set a cookie and apply it to the website. And because I wanted to make a quick demo for the purposes of this talk, I decided to use a shortcut and let GitHub's Copilot write most of the code for me. I just wrote a comment, this is the full comment, and accepted what Copilot suggested. As Copilot reached the end of each suggestion, I added comments explaining what the next step. And Copilot was great. It did exactly, and that's the key word, exactly what I said. If the query string parameter exists, a cookie is set with the value. And I hope some people can see the problems in the code that I'm attempting to demonstrate. But please try and remember what I said a few slides back. And natural language models learn from people. Copilot's educational resources are the same as everyone else's. Code people publicly have released on the internet. For displaying the discount on the page, I again let my AI friend do the heavy lifting. Anyway, let's get back to the exciting bit and buy some pears. Try not to notice the slightly different username, the different logo, and that the account is suddenly verified. Also, don't notice the awkward typo. The important bit is that the site's URL is correct, and thanks to Twitter's truncated display of links, appears exactly the same as it did on the original tweet. So what happened? How did we go from buying new season pears to giving another site our credit card details? Let's take a closer look at the discount code. Reformatted for clarity, the discount code is a URL encoded version of this. The text is the same, WCC'd, but there's a nasty bit of JavaScript in there too. On the checkout page, it looks for the credit card form, and if it exists, it alters the HTML markup to send the user to the malicious site's page. The issue comes from the code that I showed earlier that GitHub's Copilot wrote and prints the output of the discount code to the page. The easiest fix is quite simple, and to follow the advice of the WordPress developer resources and always escape your content late. So the fix for our code to stop the visitor's credit card numbers from being hacked is to escape the output. It's 8 characters, 10 with the brackets. I mean, It works. Our visitors' credit card numbers are no longer going to get stolen, but this sort of thing's not going to inspire confidence. And it doesn't change the fact that every visitor that follows the link has that data, that malicious code, stored as a cookie in their browser. And it's just sitting there as a time bomb, waiting for a developer to make a mistake. And as a developer, you need to protect yourself from your future self. The basic solution is to sanitize the data before setting the cookie. Sanitizing data means to clean up user input. In this case, we're sanitizing the data as a text field, and a built-in WordPress function that strips all the HTML markup, including completely removing JavaScript tags. And it works. We have a clean discount code containing something that looks like the expected value. So I'm glad we got that sorted. Let's move on. I'm going to discuss data that is untrustworthy. Sorry, I really wish you'd stop that. Okay, I left my computer unlocked in my hotel room last night, and I think someone in housekeeping had a bit of fun. I mean, we've fixed all this, right? We sanitized the data from the user input before setting the cookie. Everything should be fine and just dandy. Well, no, it's not fixed, because something people often forget is that user data is so much more than form fields and query string parameters. Cookies are user data. HTTP headers are user data. Session and local storage values, they're also user data. In most cases, anything stored in a cookie or in local storage is set by the server, and in most cases, the HTTP headers are controlled by the browser. However, it is relatively trivial for someone to set a cookie via the browser console, and even easier to alter the local storage. In the example I'm using today, it would be pretty weird for someone to set a cookie on their own browser so another company can steal your credit card. But what if you worked as a hotel housekeeper, hoping to find people who had left their credit cards or computers unlocked? You'd have a go. And it's important to note that escaping the output has fixed the problem, but it's also important to prevent anything unexpected from coming from a cookie so we don't end up with something like this. It's really trivial to change a cookie value via the browser console, as I said, and WordPress even provides a helpful JavaScript utility to make it even easier. For things like cookies, which we, the web developer, want to control, I think it's worth going the extra step when sanitizing and checking the data. On the highlighted lines, I'm storing both the sanitized version of the code and the unsanitized version of the code. If the values don't match, then it's not the cookie that our server set, and it should be just completely discarded. And I'm being deliberately a little bit light about the specific escaping and sanitize functions to use. And that's because it's really complex. So as a developer, you need to get very familiar and know what each function does. And there's a lot of them. So you really need to spend some time on the pages that these Google searches will take you to and learn them. As with the cookie example I used, sometimes you need to compare the user-submitted value with the sanitized version. Sometimes you need to take the input and compare it with a list of expected values. In the example of a discount code, those expected values would be a valid list of discount codes. And that's where the nuance comes into it. If you're running the WordPress coding standards, you will get a warning that the code is problematic. And that's because the coding standards don't actually run any of your code. They just look for best practices. And it's not a limitation of the code sanitization sniffs. In this case, it's an indication that dealing with user input is really complex and needs to be considered on a case-by-case basis carefully by the developer. As developers of websites, we don't get to offload our responsibilities to a piece of software. Just as we can't trust AI to write secure code, we can't trust the binary decisions of the code sniffing software to understand the nuances involved. Enough talking about visitor input on the front end. Let's look at the user input from legitimate, trusted users. By default, WordPress has 4 roles that are allowed to post content to the site. There are high-privileged users, editors and administrators, and low-privileged users, authors and contributors. The high-privileged users are allowed to use any HTML element they wish, including adding custom JavaScript to the page to show something like this, an alert. Authors and contributors, on the other hand, aren't as trusted, and their code is run through an HTML filter called cases. And this limits their posts to a subset of allowed HTML. And it's still a really generous list. It's so generous that I was attempting to animate this to make the point, and it crashed Keynote. It's generous enough that even with enough knowledge to be dangerous, even an author or a contributor can make a bit of a mess of things, while being restricted enough that these low-privileged users can't actually do damage to the website or its visitors. But consider if you're running a popular website with hundreds of employees, some of them requiring editor or administrator roles. You probably still don't want anyone to be able to do anything to harm your visitors. Let's go with definitely. You definitely don't want anyone to be able to harm your visitors. Adding the disallow unfiltered HTML constant in the WP config file was certainly one of the first things that was done when I worked for the Sydney Morning Herald and The Age. That means that even editors or administrators were limited to a subset of HTML. Now, I became friends with the product manager at Fairfax, as it was called at the time, a former journalist called Ben Woodhead. And I quickly learned a few things about Ben. Firstly, back in the 90s, when he was working as a journalist, he got a personal phone call from the then Prime Minister, Paul Keating, who called him an asshole for an article that he'd written. But in his role as a product manager, he had really strong feelings that he didn't want the website to look like this. A hodgepodge of colours with no 2 sections using the same font. So even the default allow list of HTML tags in WordPress was a little too generous. Our allow list of post tags basically became links, bold, italics and lists. And we removed some of the default attributes that are allowed too, such as style classes and so on. If you'll look closely at this list, you'll notice that images are missing from the list. That was so that we could use shortcodes and then later custom blocks to better encourage the use of captions and alt tags. Now, you may think that this shows a tremendous lack of trust in users. Surely you're thinking that the national editor of a major news outlet can be trusted not to undermine their own credibility by making their website look awful. And you're right, they probably can. But good security practices not only protect against malicious intent, they also protect against accidents. One of my greatest fears while working at the newspaper was confusing the development and the production environments. I was terrified that I'd be logged in as an administrator to the site and publish test content to the just-in section of the live site. And there were reasons that I needed to be trusted as an administrator. But let's just do a quick aside on job security. For your own personal financial and employment security, when you're writing test content, always assume that you are accidentally logged in to production. If you accidentally publish lorem ipsum to production, you'll probably get a few grumpy comments. Maybe you'll get yelled at. If you accidentally publish swearum ipsum on your website, you'll be lucky if you're yelled at. You'll probably get an official warning, and in worst cases, you might end up fired. But let's get back to actual permissions. In retrospect, when I was at the newspaper, I should have asked on the production servers to allow for developers to administer the website, but prevented us from publishing new content. Ideally, the developer team would have been able to edit existing content so we could have help journalists having problems with the feature, but not publish new content to the site. As I said, WordPress comes with a few roles out of the box. 5 on a single site install, 6 on multi-site installs. And one of those is a subscriber who can only edit their own profile. If you install certain plugins, you might end up with additional roles. For example, customers and store managers on an e-commerce plugin, or configuration roles with a plugin that's got a very complex configuration process. But really, WordPress doesn't have a role system at all. It has a capabilities system. Instead of checking if a user is an administrator, an editor, or so on, and determining what the logged in user can do from that, WordPress checks if they are allowed to do a specific activity, such as edit a single post or install a specific plugin. And for the big enterprise scale builds that I've worked on, their needs for user permissions have rarely matched the various jobs within the company. Their need for permissions have rarely matched the default roles in WordPress. The items on the list behind me are what we call primitive capabilities when we're developing WordPress. They're general rules as to whether a user can publish posts, activate plugins. But WordPress has what we call meta capabilities, and they're used to determine the particular plugin, the particular post that you can change. So, using the White House as an example, you may wish to give the Vice President's team permission to edit her biography and publish statements on her behalf, but you may wish to prevent the Vice President's team from editing the President's biography and publishing statements on his behalf. Now, I don't know if this is the case in the White House because my knowledge of the White House comes from Veep and the West Wing. And an approach you might take for that circumstance is to add a custom role for the President's editorial team with some primitive capabilities that allow for editing content that's deemed presidential. In this example, I've created a presidential editor and I'm creating presidential permissions for editing posts and pages. Don't worry too much about the code specifically. The key bit is that I've created, I'm just creating roles, edit presidential posts, edit presidential pages. And then if the post the user is editing is deemed to be presidential, we require the user to have those roles that we added earlier in order to modify the content. And an advantage of this approach is that it gives what I was actually asking for earlier when I worked at the newspaper. It prevents people that are logged in as an admin from editing the content. Let's talk briefly about hosting your site. In the local WordPress Slack workspace called WP Australia, a common question that comes up is where is the best place to host your site if you want to do X, Y, or Z? And in the WP Australia Slack, the common end to that question, the X, Y, and Z, is serve a local audience without having the enormous latency that comes from hosting content in the USA. And if you want to keep your site secure, if that's your XYZ, then there is no one best answer to any of this. There is a good answer, however, for the following question. Should you configure a VPS yourself and host your sites on that in order to save on hosting costs? And unless you're an experienced sysadmin, the answer is no. You may be able to save costs if you team up a VPS with a service that will configure and manage security updates or server packages, but please don't self-configure. In my view, one of the ideal situations is to never have your WordPress server's IP address available on the internet. And let's take a look at the 10up website as an example. If you look at the IP addresses of our server, you'll discover we apparently have 3 application servers. And if you visit the website, you get, well, not this. I got that error because at the time, I changed my browser's user agent string to pretend to be Internet Explorer 6 with just a little bit of junk at the end. And it's this little junk at the end that was getting me blocked. It's a very ham-fisted attempt to do an SQL injection attack if the server is attempting to look up the user agent. And browsing the internet with that as your user agent will end up with a much smaller internet than we're used to. And those sites that you can access will tend to look a little bit dated. You basically end up with an internet out of the 90s. So why are 10up, NPR and Discord all blocking me from accessing their site? When you do a DNS lookup for these sites, you're not seeing the IP addresses of their WordPress server. They're keeping them hidden, as I suggested. The servers, that is, the WordPress servers is the ones that actually render the website. You're seeing the IP addresses of their web application firewalls. And 2 of the sites that I included screenshots from used Cloudflare for providing the application firewall. Basically, they're looking for user input, and in my case, it was the custom user agent string that suggests that the visitor of the site may be trying to hack it. And they block that before they even get to the WordPress server. It's not a snappy headline, I know, but I can't repeat enough that it's never really a need to expose your WordPress server's IP address online. And it's one of those features, web application firewalls, that you can pay as much as you want for. But it is worth mentioning that it is included as a feature in Cloudflare's free plan. When it comes to keeping your WordPress site secure, there's no one simple trick you can do. And you need to remember that no technique will keep your site secure. If you do 9 out of 10 things right, it's the one thing that you've missed that may be enough. When working on a large project, including WordPress core itself, code review is baked into the process. It's rare that anything gets merged without another developer having a look at it. But that's fine on large projects with multi-developer teams. What do you do if you're a freelancer working alone? And as in most cases, the answer is to have a nap. Take a break from the code you were working on, work on another part of the project, or switch to another client. And by taking a break, you have the opportunity to forget the code that you wrote and forget how it works. And you get to review it afresh. And when working on WordPress or other open source projects, I'll often leave my own pull requests overnight and then go back and review them with fresh eyes the following day before requesting another person review it. Often enough, I'm happy with it, but occasionally I realise I've missed something and it needs fixing. And it doesn't matter if it's minor or major, and sometimes I've missed something major. I know from personal experience that self-reviewing code after a change of context and change of focus can be effective. And if your work situation means that that's all you've only got yourself to review code, then I suggest you give it a go. Even if you continue working on a same project, but a different part of it, you can come back the next morning and review the pull request and the code at the start of the next day. And with that as an approach, you may find you may just save yourself from waking up to a phone call from a client and saying to yourself, oh no, I've made a huge mistake. Thank you very much.